The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, and thank you for joining this webinar about the benefits of using a digital twin in well construction. My name is Kenza Lalou. I'm the Regional Sales Manager for eDrilling, and I'm here with Morten Svensson, our VP of Product Management and Strategy. For any questions during this webinar, please use the question box you will find on the GoToWebinar application, and we will do our best to answer them at the end of the session. So before we start talking about the digital twin, I would like to show you this roadmap where you can see the development of the technology, where it started, where we are at the moment, and what's our goal for the future. As you can see, we went from smart drilling instrumentation and cyber drilling in the early 90s, moving away from the drill floor into a safer environment. We then developed a dynamic mathematical and physical model and a drill well inseminator where you can train and drill a well on a simulator prior to the operation. We then had advanced monitoring, and this is where the technology adoption is in the market at the moment. If you look a bit ahead, we have automated monitoring, real-time optimization, diagnosis, and self-detection, and this is where the technology maturity is. So this is where we are now and what will help supporting robotic drilling and self-drilling rigs in the future.
So let us start with talking a bit about what is a digital twin. I guess most of you have heard this word a lot of times and have your own opinion of what it actually is. So on this image you see now, you can see on the left side you have a kind of a very kind of typically description of a physical well. So you see that you have all your known parameters about the well. You know the formations you are going to drill in. You know or you think you know the formation temperature gradient, the pore and frac pressures, and so on. And then you have all the real-time signals or the measurements from the well. So if you look at the right side, you kind of have our kind of description of the physical well. So the digital twin is a digital copy of the actual well you are going to drill or are drilling. So in our digital twin, we kind of have our sophisticated models, which are kind of fed with the configuration data. So everything that you know prior to drilling or think you know prior to drilling is fed into the system, and then it's driven by the real-time measurements from the rig. And kind of by having this digital twin, you can have a very realistic or kind of actual description of the well, how it should look like right now, according to where we are in the operations. And it has the kind of accurate and accessible data, and it contains the kind of historical data, real-time measurements, and real-time simulated data. So we are relying on dynamic models in our system, and by using kind of dynamic transient models, you are able to get more accurate modeling. If you compare it to a lot of models used in various systems is steady state models, and that gives you approximate modeling. And if you look at the main difference between dynamic modeling and steady state modeling is that you are basing that on the real-time measurements you have now, but also the history. So every simulation step is building up to where you are now. That means that you have more accurate modeling, and you can have reduced safety margins, and also have reducing your risk when drilling wells with tight margins.
So you now understand what the digital twin is, but having it actually enables additional features to help optimize drilling operations, such as diagnostics, where we do a lot of trend analysis in real-time measured data. We then compare it to our modeled data to give diagnostics and alarms to the end users. We also do predictive analytics, which are basically simulations ahead of time to look on how the well will develop. For example, we can do predictive analytics on cuttings development. A digital twin enables also forecasting simulations, where we do simulations or modeling of the entire section on the next 24 hours of the operation. And the objective is to be able to detect upcoming problems, but also to be able to do optimization of the operation. For example, drill faster, or you can decide to slow down or change parameters. So it's a feature you can use to prevent any problems in what's coming up. Another nice feature we have included in our software is what-if analysis, which is used to do optimization and run the operation more efficiently. But also with what-if analysis, you can do simulations to verify how to solve problems you're detecting. You can, of course, use the local knowledge, but it's a nice tool to have to verify your plans. Now, these features, diagnostics, predictive analytics, forecast, and what-if simulation are what you will find when you do automated monitoring and real-time optimization. But it's important to remember what you will find is that today many do advanced monitoring. And what they do is to plot real-time measurements and compare them to pre-simulated scenarios. They look at the trend to see what's happening, and that requires, of course, a lot of manual diagnostics and manual work. They might also run manual simulations when things change, but often we see that it's never done. In automated monitoring, you have real-time simulation from the digital twin, and you compare that to the measurements in real time. This enables to do automatic in addition to manual diagnostics in the operation. It also allows to detect things happening in the well earlier than a naked eye. So you can imagine with self-detection, you also have a more advanced level than what you have with advanced monitoring. In real-time optimization, there are additional features such as forecasting simulations and forward-looking simulations. The forward-looking simulations are automatic and allows to look ahead of the bit on what will happen next. Now, what we are currently developing is the automated real-time optimization, where we can have automated forecasting simulation for a very good overview of what's going to happen and how it will develop. Then you have automated forward-looking simulation, and that are already running, and the automated what-if simulations. What we mean by that, it will actually enable it will take an automatic trigger of what-if simulation to find the best solution to a problem, and also taking into account the company's procedure to solve the problems you're getting. We are also working on the diagnostics database system, which is very handy when it comes to offset wells and so on.
So now we have been talking a bit on kind of real-time applications. So let's take a step back and look into the digital well twin platform. And as you see from this slide you're looking at now, you see that we have a digital twin platform that we utilizes in all kind of parts of the well life cycle. So we use the same modeling or the digital twin in the planning phase, in the preparation, and during the operations, but also to do analysis after operations. So if you look at this next slide, you can see we have kind of also set up some benefits for the different phases. So if you start with the planning phase on the top left corner, you see that by using kind of this technology and the digital twin, we see that we can have a much higher accuracy of the plans, of the drilling plans. We have a better focus and control of the risks and uncertainty of the well, and we can absolutely reduce the planning time for planning the well. And then if you move over to the preparation, where we use the same technology, we are able to, we have a kind of a training environment or a simulator environment that allows to kind of have the entire crew and train and prepare on the upcoming well. Then you will have your teams. They will be ready and understand the well they're going to drill. They will know the risks, and they can prepare on how to handle the potential risk situation that can occur during the operations. We have also been using this same technology to test equipment and new technology. Instead of doing a lot of time on testing and training on the rig, we are able to do a lot of that in the simulator and make everybody understand of what they're going to do offshore with the new technology or new equipment. And also kind of the main focus is to kind of get a much better understanding of the well and how a well is behaving in actual operations. And then if you move over to the operation itself, by using the digital twin in the operations, we see that there is a high kind of room to improve operational predictions and get rid of operational surprises. And this means that by using kind of the digital twin as an engine with all the extra modules, as Kenza mentioned, with what-if simulations, forward-looking, forecasting, and diagnostics, we're able to detect problems much earlier than the naked eye. And this is also helping us then to avoid non-productive time. So avoid or handle much better when you get into situations with well control, detect stuck pipe prior to the personnel on the rig will detect it by themselves, other hold conditions like collapses, pack-offs, and so on. But also to have better control of the cement operation, running of casing and liner, and also completions. And all this is kind of the main focus is to get rid of sidetracks. And also by doing what-if simulations and have total control of what is going on in the well, we can also kind of improve the drilling efficiency and avoid too wide safety margins, and also to choose the optimal parameters or optimize the operations while going on. In the after operations part of it, we are running the digital twin on a kind of a log from the operation to see what's actually happened, understand what's happened, and also to find the best solutions to this to avoid this in the future. And that's kind of also use that information when planning the next well in the same area. It would be very beneficial for all the involved crew members.
So let me show you an example. We have actually done a study on over 60 wells where eDrilling digital twin technology was used either in preparation, automated monitoring, real-time optimization, or a combination of all. And what we have found is that in all these wells, there was no hazardous incidents and no sidetrack. We strongly believe that this is due to having a software that can detect at a very early stage anomalies and that can provide notifications and diagnostics messages to the crews to make the necessary changes. Moving to the visualization of the data with the digital twin, we have a 3D visualization of the well and a wellbore, in addition, of course, to the standard 2D plots. What's good to know also is that we can have the visualization in many different platforms. For example, as you see, your laptop, your tablets, and so on. Also, all the produced data can be transferred to other systems if you have your own WITSML store, for example, or your own client that you would like to use. You can also do that to look at the data that we generate.
So one thing which is quite unique by the solution we have is the real-time 3D visualization that we use in our applications. And you can see some examples on the slide in front of you right now. I'm not going to go too much into what you're seeing there, but the whole point is to be able to visualize the well in a way that's easier to people to interpret, to understand what's happening, and give a very easy to kind of operational understanding. And by using this, you are able to see when and where and how various events occurs. You can follow and monitor where the BHA or other equipment is in the well at all time. You can also monitor the cuttings accumulations and logs from other third-party systems. So it gives you a very good view on the well in a way that's easy to understand. So we have one of the key things for running this real-time system is to use the diagnostic systems, which is part of it. This means that we have a system that is quite sophisticated, that continuously monitors several of the parameters from the well. So in the diagnostic systems, we are looking at the real-time measurements, the real-time modeling output, and also the known limits or historical data that's available. This allows us to do a lot of trend analysis and so on multiple parameters. And here are just some of the examples of events that we detect. Like we detect if there's a potential influx, that is typically monitoring the pits, the return flow. It also looks at the pore pressure versus ECD and so on. We also have the potential loss, looking at also the pit volume, but also the frac pressure and collapse pressure and so on. Search Swab is doing real-time ECD calculations at all time and compares the ECD for the entire wellbore against the pore and frac pressure. We have the impending stuck pipe, where we are continuously monitoring the modeled cuttings concentration, but also looking at the hook loads and the trend deviations there. It's the same thing with the pore hole cleaning, which is pretty much the same thing. But we look at it also against the forward-looking simulations. So we look ahead of time to also detect potential problems coming up.
As you can see here, various clients, not only in Norway, but also all over the world, have been using the digital twin and eDrilling products for the values it brings. Something to notice here that we've been not only working with oil and gas operators, but also with service companies. And this is mainly because our products can easily be integrated to any of their in-house system. So to conclude, I would like to summarize the benefits of the digital twin. It's a technology that is available to you not only to optimize drilling operation in real time, but also in the entire life cycle. It's also there to prevent incidents and avoid NPT. We can now move to the Q&A session. I would like to remind you that there is a tab in the GoToWebinar application where you can ask all the questions you have.
Yeah, we already got a lot of questions, so let us just start to see answer them as good as we can. Yeah, we can start with this one. What are the inputs or data you need to create a digital twin environment? And I can take that fairly easily. We are relying on some of the data that you already know about the well. So we need to put in the formation properties, the pore and frac pressure, collapse pressure, the temperature gradient, the casing design or the casing program, the BHA to be used, fluid properties, and then we just use the real-time measurements, and we use the surface as measurements, so the rotation speed, the flow rate, the rotation, the movement of the string, and so on. And then we use the downhole measurements for calibrations. So we can calibrate if we see that very often there is some inaccuracies in the configuration data that we get from the companies. That might be inaccuracies due to bad planning, but also because there might be something that you don't know about the well. And then we can use and tune the measurements against the model. Another question, how much time does it take to create a digital twin? Creating a digital twin is not very time consuming. What is the time consuming part of this is to get all of the data that we need to do it. That is actually just due to that most of the oil companies that we meet, they don't have a very good data management. But we see that most of the oil companies today, they are getting better and better control of their own data and have systems or databases with the data. And in those cases, we actually connect to the databases and collect the data manually. That actually means that if something is changed as well in the well design, we can do a very quick check and collect the latest and greatest data set. There's another question here.
It's also related to time, how much time it will get to get the simulation done and the results interpreted.
Yeah.
So it's similar to the previous question.
Yeah, but it's quite interesting because time is, since we are, if you look at the digital twin as kind of in the different phases, if you look at the planning phase, it takes some time to kind of model the drilling operation of an entire well. What we see is that the time consuming there is depending on the data power you have. But to do it in real time, there is kind of then it's calculated in real time. And if we get real time measurements from the rig in 1 hertz, we are able to kind of do this really quickly and get the simulations done. And typically simulation time for one kind of complete cycle for the well is typically 100 milliseconds or something like that. So you will get the results mostly in real time. And since you are kind of asking about time, we are doing the interpretation in real time as well. So when we, for example, are looking at, if we are doing trend analysis, we will give a warning very early based on the measurements and the modeling data that we do. And it's kind of it's very easy to say very early, but we have seen that we detect problems a few stands before the problem is visible for the naked eye, for example. There's a question about how can you tell that you have high cuttings concentration downhole. So our hydraulics modeling is calculating the cuttings concentration and the cuttings, the lift or the slip. So we have a really good control of how the cuttings is accumulating downhole. But of course, to get that accurately, we need to be able to know something about the cuttings. And we see that from some operations we can get, when they measure the cutting size offshore, we can update that in the system and we will get the same results. And we see that it seems to be very, very accurate. Yeah. And then we have another question. What are your commercial models? How does this service is charged? Yes. So we have a very open commercial model. I would say we have 3 different options for the end users. The first one, which is the traditional, where the end users buy a perpetual license of the software and are free to use it as they want to do themselves. The other one is software as a service. So then the customer rents the software on a kind of defined timeline. And then it's easy to scale up and down based on the needs from the customer. And the third one is to kind of not only have the software as a service, but actually have eDrilling as a service, where we use our drilling engineers to support the operations. Yeah, let's see if there's another question here. Yeah. There's a question, what if the well is an exploration well where the data is limited or basically derived from nearby or far away wells? Yeah, that's a really good question. And that is where it comes into the accuracy of the data. There might be some unknown, and it might be, for example, the pour on frac pressure and collapse pressure might be not too accurate while drilling, and then it might not be the best way to do diagnostics on that. But usually when you are drilling, you will be able to update these things on the fly, and the system can take these last updates while doing the operations. We have seen that the interest from our customers are very often on exploration wells because of the higher risks. But we see that the benefit of using the digital twin in kind of more well-known wells, like in factory drilling and so, is also very useful, because then you know more about the wells. But in exploration wells, we kind of we tune us against the measurements to make sure that we are correct, and we do that in the beginning of the section. And as things start to deviate between the digital twin and the measurements, we know that there is something going on. So it's very useful in those kind of situations as well. One question, is your digital twin connected to well in operation, and does it use these data to update the models? Yes, we are connected. When we use the real-time system, we are connected to the real-time data stream from the rig. That means that that is actually driving the models or the digital twin. Yes, and we do update the models on the fly when needed. This means that if we see that something has changed, something, we can update it. But on the same time, we can use the downhole measurements to calibrate the model whenever we need to. Of course, we don't do calibration all the time, because then we would very often not detect problems that actually occurs. Yeah, there is a question. How do you import the contextual info, formation, BHA, and so on, if it's not available in XML format? Yes, really good question. We have customers using XML warehouses with all this data available, and then it's imported directly. We have other customers having other data warehouses, databases, and then we have made some modules that can collect data from other systems as well. But in some cases, the customer doesn't have systems where the data is easily available in a computer way. We can add the data manually by copy and pasting, for example, or writing directly in. And that sounds like a big manual job. And of course, if you're going to write in the entire survey into the system, that is time consuming. But most of the data is quite easy to import. But it makes it very easy because you can import the data from the other sources, and then you can look at the data and verify, and we do quality checks on it to make sure that it's possible to do it. Another question, is it possible that technology launched the scenario-based forward-looking simulations automatic based on current operational anomalies? Yes, that is the kind of the next thing we are working on. So if we not, because now we do, all the time we do forward-looking simulations, and that is based on the current digital twin. So every kind of time step in the real-time simulation, we take the current status of the digital twin and we do forward-looking on that data based on the current drilling parameters. Then you have the what-if simulations where you can also do a simulation and alter some of the parameters to see how that would look like. And the next step which we are working on is that when we have a diagnostic triggering, we can then run an automatic what-if simulation to find the best solution to avoid this problem. So that is the next thing that's coming. There's a good question. Do you use AI or machine learning to forecasting purposes, or will forecasting be based on your mathematical models? If it is based on simulation models, the models should be calibrated with real-time data, correct? Yes. Our simulations are based on physical models, and that is kind of our base technology. And of course, when we do what if and forecasting, they are calibrated with the real-time model that we use. But we use some kind of machine learning to detect various problems. And I think that is the best way of using that kind of technology. So we have a few more questions, but we are actually over time. So I would like to thank you all for attending this webinar. If anybody wants to know something more or have some questions or something, you can please just contact me. You probably got emails from Morten Svendsen of reminding of the webinar. So please feel free to contact us, and we will get back to you with whatever you are need to.
Yeah, you can also find all the slides we presented today in the handout material on the GoToWebinar application. So thank you everyone for joining, and as Morten said, don't hesitate to contact us if you have any questions.
Yeah, thank you.
Thank you.
Bye.